Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. For those of you who are new to the show, let me tell you just a little bit about what we cover in this podcast. So the concept of Data Unchained is talking about the tools and technologies that have been evolving as data became increasingly decentralized. You can imagine 20, 30, 40 years ago, a lot of the enterprise solutions that were built around the concept of a large mainframe and the people and the building and everything around it being right there with the compute environment. And now as data is being created all over the place off of our vehicles, our phones, our medical instruments, rockets, and then spreading that across data centers and clouds, a lot of new evolution has occurred in how do we design not just infrastructure, but access to those data sets. And so this podcast jumps into what are some of the challenges, some of the solutions, and the business opportunity if you kind of get into the modern architectures for distributed data. Without any further ado, let me introduce today's guest. Dia Ali is the Global Platforms and Solutions Leader for the Unstructured Data Intelligence Group at Hitachi Vantara. Welcome, Dia.
Thanks, Molly. Thanks for the intro. Yeah, great to be here.
And you're, of course, a ideal candidate for being a guest on this show for a lot of reasons, with a lot of opportunity to touch both the data and the infrastructure side and, really large enterprises. So we're really pleased to have you on today's show. Before we jump into the conversation, maybe tell us just a little bit about yourself. How did you end up where you are today professionally?
Well, thanks for having me first. I think this is a relevant topic with everything that's going on. So I did jump a lot of organizations throughout my career, ended up in Hitachi, working for the unstructured business, mostly on the object storage and now recently the AI space in Hitachi. Did work for organizations like GE, AT&T, financials like Morgan Stanley. So kind of different businesses, which kind of helped me kind of develop some kind of understanding of how different businesses kind of deal with their data, how they kind of architecture their systems, what challenges they have. So I was lucky to kind of jump different verticals to get to where I am today. So that was a good mix in my career.
Absolutely.
Up till I got to Hitachi. Yeah.
And those verticals, certainly, when you think of unstructured data, are some of the really large data creators in that space. It's been interesting to see this shift that's occurring in the world right now of, well, unstructured data is not new. And I think I haven't asked you about this, but my perception is a lot of it was focused on how do we store it, just because it was really big and how do you do that cost effectively. And now we're shifting to what is it and how do we use it has been a really interesting shift in the last few years.
Just like you said, yes, we were generating a lot of these. And when you say unstructured, we, just to simplify it for the audience, it's, documents, PowerPoints, images, videos, all of these have been we've been storing those without understanding maybe the value that we can drive out of it. And I think now that we have all the tools necessary, now we're going back to saying, okay, let me go back and get more value out of that data that I have been storing for a long time. And over the years, I think people started to kind of move the data around where they used to store it on block, which is this storage arrays and file systems. And with the explosion of the object storage services, like 10, 12 years ago, that was a perfect target for that data from a scalability perspective, from the services and tools that were available at the time, but we did not take advantage of, namely metadata, which is attributes that can describe that unstructured data or turning that unstructured data into a structured format or semi-structured format I can better understand and process. Now we're going back and saying, okay, let me go and see what I can do with this dark data that I used to have in my in my enterprise.
And is that what your group at Hitachi is focused on? You have kind of a broad span, it sounds like, with global platforms and solutions, but tell us a little bit more about what does your group tackle?
Our line of business, the AI and unstructured data business, focuses on providing customers with solutions that help them in this explosion of AI, and everybody's talking about AI now. So our team helped build an AI-ready infrastructure for those customers that are looking to dive into AI, but they don't want to deal with, say, the infrastructure side of it because of complexities, time to value. So we kind of build those solutions for those customers, and we're recently focusing on building services on top of that AI infrastructure to provide an end-to-end option for vertical to take advantage of the AI, as well as we obviously Hitachi owns an object store, so we also provide services and solutions around object storage, whether that is cloud-based solutions. When I say cloud, I know people think of AWS, Amazon, Azure. When we say cloud, I just mean a location. That location can be on-prem in your data center. It can be a managed service, a hosted location, but cloud-like services for the enterprises. Also, we do have file systems and block devices for those customers. So we take advantage of everything that Hitachi creates and manufactures in the infrastructure space, where it kind of focuses on data storage, and we bring in the solutions aspect of it to provide customers with a ready-to-go service. That service can be infrastructure, it can be software.
You mentioned AI several times in that intro. I think it's on most of our minds in a lot of different ways. Yes, absolutely. So with the experience you have with Hitachi's customers, which is a really nice data set of different types of markets and different geographies, everything is such a large global company. What are the key inhibitors you're seeing right now of implementing AI or success in AI projects?
I mean, that's a great question, and I think this is the like us addressing the elephant in the room, if you will. what's actually holding AI back. I think when talking to enterprises and customers that we deal with, I realize that it's not that enterprises don't want to innovate. It's that their data is a mess. And when I say a mess, I don't mean the actual data itself, but when you look at the enterprises, they mostly have fragmented data across systems. They store it in different formats. There's no shared visibility, and they don't even get me started on governance space. I mean, who owns the data? Who owns what? Who can use what? What's compliant? There's just no alignment, I think, in these enterprises. And then there's the security side. You've got data scientists pulling copies of data sets, building models in silos, often with very little oversight or policy enforcement, which is risky, not just for compliance, but for trust, which is what you need to build a scalable, responsible AI. So yeah, the blockers aren't lack of, say, models or compute, because we have access to those. It's just the data plumbing and trust that surrounds that data. So I think, in my opinion, those are the inhibitors for AI.
It's been interesting running this podcast and some of the guests that we've had on over the past year. One of our guests was a gal who wrote a book on data governance, and I won't get the quote quite right, but it was kind of funny. She's like, no one really was interested in talking to me 5 years ago. I wrote the book. It had lost vogue. Only a couple people in the corner in the basement in the enterprise really wanted to think about governance. And she said, now all of a sudden everyone wants to talk to me because governance has become important again. And I feel like with AI, a lot of things that we just kind of put to the side and said it's not that important to staff and budget for. We'll just lock it behind a firewall, lock it in a data location, And then we don't really have to have a policy around it or worry about it. It kind of feels like it was put to the side. And a lot of the topics that you're talking about now are front and center if you want to do AI. Are you experiencing the same kind of shift that organizations are having to put policies in place that they just didn't bother with 2 or 3 years ago?
Yeah, absolutely. And I think one of the key drivers for that topic is trust, especially if you think of 5 years ago to the comments that your previous guests had made. If you think of our interaction with the data before the explosion of AI and the capabilities and the infrastructure that allowed us to go as fast as we can process data, at that time, while security and compliance and governance have always been front and center, should have been front and center, it wasn't a focus area, to your point. If I put it behind my firewalls, I'm good. But with the explosion of AI and the capabilities of data processing, now people started to kind of go back to say, okay, you know what? All of these AI models and tools that are starting to impact our lives, that are making decisions on their own, in some cases with some AI autonomy or AI agents, can I trust that decision-making process? Are there any biases that can impact the outcome, that can impact society, maybe at some point? So I think people are going back to addressing that security and governance nature. And this is what is driving the whole notion about, a responsible AI, if you heard that term in the industry. I want to build a responsible AI. What that means, I think, to enterprises, which kind of provides emphasis on governance and trust, again, is the ethical safeguarding on and transparency practices that people are starting to adapt inside of their AI model. So if I'm building an AI model, an AI pipeline, if I'm building an AI agent, I need to be able to explain the use of the model, like the reasoning behind some of the decision making. I need to be able to audit and trace all of the AI actions that have been taken. I remember a phrase in that topic which kind of stuck with me. I can't remember who made it, but I've heard it in one of the discussions with customers. They were saying accountability begins with visibility. So if we don't have visibility into how those actions are made, there are no accountability. And again, I think the main focus for governance and trust is in the bias and fairness nature of the new platform that we're dealing with. So I think, I would say trust.
That makes sense. Absolutely. Thinking about some of the solutions that are evolving to help with this kind of set of problems that have evolved over the last few decades, trying to transform into AI. I know Hitachi has an AI factory, and I think it would be useful to talk not just about what does Hitachi IQ do, but more generically, what is an AI factory and how does it help customers as they're embarking on this journey?
Just to simplify it, I live in the Detroit area, so for me, car industry kind of all around me. So I think of a car factory where they have a production line. At the end, you manufacture a car. That's a product. That's what AI factories are. They're a repeatable pipeline that take on raw data, apply policies and security controls to deliver a trusted output. That's an AI factory in like a very, very simplistic, high-level view of what that means. If you, just to give another example of it, if you think of supply chain for, you can throw in data and models together and expect values as an output for that. But you need structure before you can do that. So if you think of how critical the different pipelines that follow each other. So you have to have kind of a handshake or handover between these pipelines, and that's what an AI factory is. It's just a bunch of stages that take on data to create an outcome, and within that black box inside the factory, there's a bunch of stages that you have to go through to generate that outcome or output or product.
It's interesting to think about, how do you deliver an AI factory? And you certainly feel free to just talk about this in the context of Hitachi IQ, but
Sure.
Is it a box? Like, do you deliver a box and people put data in and it churns it and out comes AI? Or is it like a set of policies that folks are driving in their business? Maybe just talk a little bit about what is it?
Got it. Most of the AI workloads, infrastructure is definitely one of the main components where you need an infrastructure that can process data, not data, but a large amount of data at considerably fast speed. So infrastructure is key when it comes to that AI factory. Just like when you go to a factory, you have all of these machines that kind of produce the products and the goods. If you can produce 10 compared to producing 100, that's the difference between making more revenue. So similar to that, you need an infrastructure that can kind of run your AI models that you put together to produce the outcome. So an infrastructure is key. And in Hitachi, we've created this Hitachi IQ platform, which is like an end-to-end stack that people can use to run their models on. So that's the first part in that AI factory, so the infrastructure. And then you have to look at the different models that are available for the specific use case. For example, an AI factory for healthcare may look different than an AI factory for financial institution. The models that you use for each one of those will be different. So, and like I said in the beginning, an AI factory involves multiple different stages. You take data from different data sources, and then you push it inside a model that you have developed or acquired for retraining. You train that model, you train the data, you look at the output, you look at the outcome, and then you retrain it again and you feed it back again, and you continue to do that all over again until you get to the outcomes that you need. So from that perspective, that's what constitutes like an AI factory. So there are multiple stages. Infrastructure is definitely key.
Who typically is responsible for running, selecting, deploying the AI factory?
Oh, it's multiple teams. It's not just one team. So you have the IT, the infrastructure team, the infrastructure pieces. You have the data scientists who are kind of looking at these different models and the data pipelines and data preparation and these different algorithms that they use to create those models. And you have the business owners or the stakeholders who are funding, let's say, these projects, these factories, if you will. They're expecting certain outcomes. So it's not just one team, it's multiple teams working together. And this is where AI was initially not easy to scale and adopt because these teams have had challenges in the past. They were siloed, separate, they were never talking to each other. And now they have to kind of work very closely together to deliver the outcomes that the business is looking for. So it's not just one team, it's multiple teams working together.
I think another shift, in addition to the organization structure really being different and trying to get access to this fragmented data you talked about earlier, is the overall idea of thinking about data as a product. You mentioned this in one of our prep calls that,
right.
I think data is now driving so much in the business. And we've been saying that for a long time as an industry, but it's really the driver for not just product development, but business processes, insights, competitive analysis with AI. I would love to talk a little bit about when you think of data as a product, are you thinking about that as the what we're feeding into AI models, or what are you thinking about when you think about data as a product?
Data is not just an input; it's a core asset, and if you want it to be useful across the organization, it has to be usable, has to be discoverable, and we always say it has to be self-describing. That means, rich metadata, ownership, versioning, all the things you expect from the data. When you start to think about data like a product, everything starts to change. Suddenly, you're not just managing infrastructure, you're managing value. And I was talking to a friend about this concept, and he said, yeah, well, that's storage by intent. And it's a perfect description of that, storage by intent. So you're delivering data sets with SLA, quality control, and governance baked in. This is, like I said, storage by intent, as described by this good friend. And that's what unlocks, ethical, scalable AI, because now you know where your data come from, what it means, who touched it, and how it should be used. That's not just good hygiene. It gives you competitive advantage. So this concept of data as a product, I think once we start to look at data as a product with owner and a roadmap and access controls around it, and now I have data sets that are discoverable. I have data sets that are trustworthy because I'm going to build lineage and validate, and it's more secure. It's more usable because now it's not fragmented. I have controls over it to say, yes, this data is needed for that project. This data can be useful to give you these outputs, these outcomes. This is what you use it for. So when I start to look at it as not just input, but more of a product I can use to build an outcome or a model that changes the organization, focus on some of these AI projects, and it will make some of these AI adventures and kind of proof of concepts much more useful to the enterprise.
You mentioned the word self-describing a few times.
Right.
I mean,
Yes.
gosh, wouldn't it be wonderful if it had always been self-described, because it would be easier to track all these things down. Maybe dig in just a little more deeply into how. Is this happening within the file systems and object stores? Is it at the workflow level, or the data creating humans or machines creating the descriptions? Maybe talk a little bit more about that.
Yeah, thank you, Molly. I think when we talk about self-describing, let's start with the object store, because that's where. Let's start with the file systems, because that's older than object store. File systems have always had attributes, like we call them system attributes. Like if you have a document, that document has a name. You can have a size, an owner, who created it, when it was accessed, when it was modified. All of these attributes are describing that document, but those are like system data. There are some, you can get some insights from it, but it's just very basic. And then came the object store with an architecture where data and metadata are kind of separate. Now, all of a sudden, I can add a lot more attributes on top of that data that the file systems could not do at the time. However, when object store came to be, there was not a lot of applications and use cases to take advantage of that capability. Not until recently, where we started to, look at this metadata as, hey, I can, structured my information based on attributes that the data set can carry along with it whether that is, owning your own metadata, owning your schemas, the policies, the usage guidelines. Imagine if I have a data set that has all of this. It has the schemas, the policies around it, and how to use it. When I say how to use it, can you use it for, to process health kind of pipeline? Can I use it to provide insights into a customer transaction because I needed part of my marketing campaign to do like a customer 360? So if the data can carry all of these attributes along with it, doesn't matter where it's stored, where it's located, whether it's stored in an object store or on a file system, and there's not a lot of file systems out there that have the concept of enriching the metadata. And I know this podcast is supposed to be generic, but look at Hammerspace. They have this, great engine in the metadata and custom metadata space. So that they started to bring that concept into a file system where now my data set are self-describing. So whether I'm storing it on-prem, in the cloud, somebody else's cloud, somebody else's storage, the data self-describe what it needs. It can describe how it needs to be protected, where it needs to land, what geographies I'm not supposed to cross, or what borders I'm not supposed to cross, like GDPR and geofencing. And now all of a sudden, the data is much more useful to me. And wherever it goes, I can apply a policy, and that policy will be honored regardless where the data is located. So now my data is more secure, much more secure.
That's a big change, isn't it? Yeah. Thinking about the AI factory being a single entity, so to speak, that you can apply policies to locations, different infrastructure types, things as things are moving around. I think that's really an important point, that you can now adhere to whatever decisions you make based on this self-described data. Exactly. What can leave, what can't, and it's not a human copying it or 16 different copy packages. It's actually managed by the AI factory, right?
Exactly. And it ties beautifully into that AI factory that we discussed earlier, because you can have a reliable, automated, scalable AI pipeline unless the raw material or your data is consistent, high quality. And how do you determine this data set is high quality or not? That's you can start to look at the attributes of that data, whether that is, like we talked about, the usage pattern, the usage guidelines, the policies, the schemas. This is where this self-description nature that is empowered by metadata and custom metadata enrichment. So if you have a platform that can enhance the data by providing all of these colors on top of the data, now when I'm feeding it to this AI factory, the data can flow freely without a human deciding where it needs to go quickly, because computers can act faster than can we do. So that data can flow freely based on the outcomes that you're trying to accomplish in that AI pipeline or AI factory.
You made that point, and it's something I think about a lot, that humans can't manage these pipelines anymore. It's just, there's too much complexity, too much speed, too much volume. So that automation, but under human control of what happens, is really important.
Hopefully it will be under human control, especially with this explosion of AI agentic autonomy that is started to surface now, and we're seeing some use cases and deployments of some of these systems. I mean, it's crazy the amount of data we need to process and the outcomes. It's impossible for a human to. However, I think going back to your friend's comment about compliance and security, I think for these systems to be successful, they need to still have what's called in the industry a human in the loop, like HITL. Concept, so that, for example, when the AI agent is making decisions, a human can approve that decision, look at the outcome, approve or not. Think of doctors nowadays. There's a lot of AI automation that provide diagnosis to, like images and diseases. At the end, a human will have to look at the decision that were made by this system. So yeah, this diagnosis looks good. This, just matches. So you'll have some human in the loop at some point. And at some point in the future, you will start to kind of remove that part, but add a human on the loop. So while AI agents are making decisions on their own based on the models that have been tested and validated, I will still give humans the ability to override that decision at the end, but allow the AI agent to go as fast as they can. Initially, there has to be an AI-human collaboration until we get to a point that these models are trusted, validated across, not only just, tested multiple times, but they need to be tested across, let's say, different demographics, tested with different workloads, different data sets, and at the end, those systems will definitely benefit from that self-describing nature of the data.
You mentioned something that tested across demographics is a really interesting concept, and we can't go into every topic we're touching on. You could do a whole show on agentic AI and demographics and all that.
Absolutely.
But we were having a conversation on this show a few weeks ago about it was a driving example of self-driving cars and how the algorithms and the models around self-describing cars have largely been tested in big cities and the complexity of big cities. And then you go implement them in a culture where maybe people walk on the street a lot and don't adhere to stoplights and, things like that, where, there's lots of places where there's a lot of foot traffic, and those algorithms aren't really designed and tested real well in those areas. And not that something really bad happened, but, just that there's a lot of work yet to be done, for sure.
Correct. I think we have to start somewhere. I mean, starting in cities, I think that's easy because that's within city. But like you said, rural areas where different conditions, even cities that have different cultural norms.
Exactly.
Where these things were tested will make a big difference.
Absolutely.
And like I said, this is where, again, if you go back to that AI agentic, like since you mentioned self-driving cars, I gave an example the other day about GPS and self-driving cars. So think of GPS as the legacy, where GPSs give you navigation decisions, where self-driving cars are this AI agent that collects data from different sources, driving conditions, regulation, local regulations, pedestrians crossings, sensors, and it has to make a decision, split-second decision, if you want to make a left or right type. And even within the states, there are states where you have to make a left to make a right, if you know what I mean.
Exactly, yes.
All right, so all of these are decisions which, if you think about it, a car is an AI factory at the end of the day as well. It's taking all of these different components and try to make a product. The product is the convenience of humans, where just the car is driving itself.
So when you think about all of this coming together, there's a lot of evolution, and I know you're working on a new series of articles right now that is introducing yet another complexity, the convergence with all of this with quantum computing. But maybe just tell us a little bit about what is that series kind of, as you're thinking about this progression and how this all ties together. I'd love to get a little insight, and then we, as the articles are available, we'll certainly link them into this show as well.
Yeah, absolutely. So if you think of AI and quantum, I mean, quantum has been an interesting topic for me, at least in the last 2-3 years. The technology that we have access to do when it is with quantum, while it's not mainstream and ready, we're starting to see convergence between AI and quantum. And if we look at what I call the evolution timeline of, this convergence era. You have this AI maturity where we went from being experimental to being more practical and scalable when it comes to AI applications, and then evolving into the AI autonomy when things like AI agents, self-learning, self-decision making. We went from like the ChatGPT, where I'm using ChatGPT to help me with my classwork or my homework, to now they're making decisions and self-aware, if you want. And the next phase of this evolution will have to be quantum, because if you look at the capabilities of what quantum can do, quantum computing, to help accelerate these AI capabilities at some point. So from that evolution, it naturally flows, and quantum is going to have a lot of influence. It's not going to happen today, but like maybe in the next 10 years before we can see that convergence. However, if you look at also and I'm arguing in these articles that in the AI maturity space, if you focus on the first evolution, going from experimental to application, there are three concepts that I kind of started to think about whenever I kind of think of a topic or a use case or a solution. So we have the hype around the technology, and we have the reality of how that technology is going to be deployed and used, and we have the impact of that technology in our daily life and different verticals. So in these articles, I'm arguing, what's the hype and what's the reality of the systems and where that is impacted. But at the end, I think when I think of AI, because that's just everyone's saying, AI is no longer a promise. It's more of a platform for progress. That's how I think. If I want to put like one single statement, that's how I think about AI.
And this is your chance to predict the future, which is kind of fun to consider.
Crystal ball.
Crystal ball moment, okay? So 10 years from now, who will own a quantum computer?
That's a good question. Definitely not me. It's not individuals.
It doesn't seem that way.
It doesn't seem that way.
And for show listeners, if you haven't seen an image of a quantum computer, go Google it, because they're very specialized in, even environmentally, in what kind of environment they need to sit in.
So I think the big tech. So today we know Google, Microsoft, Amazons of the world, they own quantum computing. Governments, those are the ones that can afford owning quantum technology. And I've been reading about what Microsoft has been doing in quantum. They've already started to create models, and they look at the model like, this is not what we expected, and they just scrape it and they start all over again. But these projects are not your like 1-2 week projects. They take a couple of years before they even get a model and even deploy. So I think those big tech, they own quantum. However, the ownership of quantum does not necessarily mean that we, individuals and businesses, will not benefit from that. Think of like the ChatGPT, OpenAI. They own large amount farms of GPUs, and they create models and they train them. But we kind of take advantage of it as a service. So I think, while big tech will own creating these newer services, the AI agents, and I see quantum and AI more useful for these, self decision making services, especially if you think of let's think of different work. It's easy, like healthcare. Today we're doing some diagnosis with quantum help and AI. In the future, quantum helping AI to be much more scalable than what it can do today. We can, in the future, instead of taking, a year to develop a drug, we can take maybe, let's just say a week or a few days. We can even get to the point where that drug can be specific for this individual at some point, if we want to kind of imagine.
Huge benefits to society.
Yeah, huge benefit, exactly. And I think this is where hopefully those big tech are looking at advancing society and humanity when they're looking at these technologies. Of course, they have to make money in the process. We're not naive, but if they keep society and humanity in mind, I think it will be very, very useful.
Absolutely. And that's always been the case with even
Correct.
thinking about drugs. Sure, the pharma companies need to make money, but it's for a good cause. And it certainly seems like the two come together. I was in Paris at a conference on quantum computing maybe 18 months ago, and one of the first codes that were running on the quantum computers were around weather forecasting. And, they weren't perfect by any means, but they were showing how much better they can predict and how much more quickly they can alert. And that's a really exciting use case too, as you think about.
Exactly. Yeah. That's, again, like we deal with hurricanes in the US and multiple areas. So imagine if I can alert you a minute or two before, that would give you time to get to a shelter faster.
Exactly. Good stuff. So, Dia, as we kind of tie up the conversation, I'd love to ask you a few kind of your perspectives on some of the future-looking pieces of AI. Maybe we start with the biggest kind of positive. What is your hope for where AI is going to take us?
It's something that we need to all think about. I think my greatest hope, or my hope for this technology, is for us to create a collaborative intelligence, to have a future where humans and machines are kind of co-evolve and amplify each other's strengths and solve problems that we cannot or could never tackle alone. And this is where the explosion of this autonomous AI agents or AI agentic kind of movement, I look at those AI agents and I hope for them to become partners in progress to unlock new possibilities in things like climate, medicine, and global equity for us. So that's my hope for the technology going forward.
Do you feel like there's any big risks or pitfalls that we should be on the lookout for?
Yeah, there's always that concern. I mean, in our race to innovation, we sometimes forget to govern, which, going back to your friend's comment about security, and now everybody's talking about, I'm concerned that when we deploy systems that are too complex to control, and in environments that are too sensitive to fail, I think. So my concern, I don't want to say fear, my concern is not AI domination, which is kind of what everybody's fear of, like AIs are going to take over my jobs and machines, and we're going to go to this matrix type. No, that's not. I think it's not AI domination, but human negligence. That's my greatest fear. Where the greatest risk isn't the machines themselves going rogue. It's us giving up responsibility before we're ready and fully prepared to give some of that responsibility to those machines. That's my concern.
And we've already seen a little bit of that. Sometimes funny, sometimes not. Examples of using ChatGPT to create content for you, and then it turns out it's not right, and but the human didn't edit it or review it before they submitted it. We've had countless examples of that. Where I think we've already seen examples of it's a great tool, but don't give up control or too quickly because
too soon.
It can cause problems for you, for others. And so I think keeping our finger on the pulse of that as the market evolves. Because that example will change, but it will be the same kind of comparison for sure.
Absolutely.
Yep.
Absolutely.
I think the classic saying people are starting to use quickly is that AI won't take over for humans, but humans need to know how to use AI in this next generation of the world, and that's absolutely true.
Yeah. I mean, that's just technology evolution. I mean, it's shifting. Think of the world 50 years ago. The kind of jobs, the kind of things you used to do have evolved and changed. And AI is nothing different. It's just the job you're doing today, the task you're doing today are going to be changed, and you have to embrace that change and just educate yourself on it. So don't be afraid of AI. It's not going to take over the world, but it's going to hopefully it's going to make the world a better place.
Absolutely. Yeah. Thank you, Dia, for joining today. It's been a pleasure.
Yeah, thanks for the invite. I've been watching the podcast series. It's great. Thanks for inviting me and having me to be a part of this.
Absolutely. Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.